Before we start creating logic tables, we have to make sure that we are familiar with the logic operators. Here's a little bit of a short primer on logic operators. The negation of P, whenever P is true, negation is false and vice versa. So easy enough to remember. P or Q. P or Q is true if at least one of these statements is true, either P or Q or maybe both. So the only time it's going to be false is when both P and Q are false. So here is a hint to remember the truth table for P or Q. P and Q. Similarly, P and Q is true only in one situation, when P is true and Q is true. If at least one of them is false, P and Q is false. And the conditional statement. P in the conditional statement we call antecedent and Q we call consequent. This conditional statement cannot be reversed. For example, P implies Q is different from Q implies P. This is false only in one case, when P is true and Q is false. Any other truth value combination, P implies Q is true. The last one is P if and only if Q, what we call biconditional. We also write it as PIFFQ. And that is true whenever both P and Q have the same truth value. Either both of them are true or both of them are false. If they are different, P if and only if Q is false. Let's try an example. We have to create a truth table for the statement negation of P and not Q or P and Q. When we want to create a truth table, first thing we need to do is recognize the simple statements in the given compound statement. So our statement is made up of two simple statements, P, Q. We need to create the truth table, so for every possible truth value combinations of P and Q, we know the truth value of the compound statement, the given statement. So just like when what we did with sets, when you build a truth table, we have to do one set operation at a time. So this is one of those very first ones we can do, taking the negation of Q because we already have Q. Then we can take P and not Q. I'm labeling the operations we are working on in red, so you see that we are only doing one operation at a time. When we try to do AND operator, we already have P and we already have negation of Q. If not, we have to go back and get the truth values for those things. Next, we can negate the statement. We already have P and not Q, so we can take the negation of that. Next, we can create P and Q. Now we have everything to evaluate the O operator, and this is our the compound statement. So you see, truth table is made up of three parts. The first few columns represent truth values for the simple statements the statement is made up of. In our case, P, Q. Part of the table is for us to step onto the compound statement we are creating. Negation of Q, P and not Q, negation of P and not Q. P and Q all are stepping stones to the statement we want the truth value for. So let's fill this in. There are four possible truth value combinations for P, Q. Both are true. P is true, Q is false. P false, Q true. Both are false. Those are all the possible truth value combinations. Negation of Q is easy. You just invert the value of Q. Whenever Q is true, negation is false. Whenever Q is false, negation is true. And from what we did earlier, is true only when both the statements are true. So first line TF gives me false. Second one, P and not Q both are true, therefore it's true. Third and fourth rows, P and not Q is false. negation, again we have a statement P and not Q. We just negate its value. F will be T, T will be F. So we get T, F, T, T. AND operator, again, it's true only when P, Q both are true. So T, F, F, F. Only first row T and Q both are true. Finally, the O operator. O is true if at least one of the statements is true, or equivalently, it is false when both statements are false. So, first row both are true, so it is true. Second row both are false, therefore O is false. Third and fourth, one of them is true, therefore the O is true.